Have you ever wondered why the moon doesn't fall into the earth? Thanks to Newton, we know that gravity is the force that keeps us and the moon from flying off into space. But if the moon is kept in orbit by gravity, then why doesn't it fall like Newton's apple? The answer is because of the centripetal force. The moon is orbiting in a circle, so it's constantly accelerating in a different direction. Originating from Newton's first law that any accelerating object must have a net force acting on it, there must be some kind of force keeping it in motion. The moon's circular motion is due to the centripetal force of gravity that allows it to fall around the Earth with a tangential velocity, much like a satellite. However, although the centripetal force would be gravity in both cases, the magnitude of the forces would be different. Centripetal force varies from situation to situation and is determined by three things. The centripetal acceleration, which is dependent on 1. The tangential velocity, and 2. The radius of the circle. Velocity is squarely proportional to acceleration and force. So if you triple the velocity, the acceleration and force would grow 9 times. But if you were to spin the same object using the same force with half the length of string, the force would be doubled. And third, the mass of the object undergoing circular motion. The larger the mass, the greater the centripetal force required to keep it in motion. Centripetal force isn't only limited to gravity though. It can be normal force, tension, or even friction like in a car. When a car is moving, obviously inertia will want it to continue in the same direction. But imagine riding in a car that can only go straight. You're probably going to end up crashing if you don't turn. Thankfully, we have the centripetal force of friction on the tires. Technically, every turn is part of a circle, so we have friction accelerating the car in a centripetal direction inwards, not outwards, like the common misconception. This is the concept of a centrifugal force, when it feels like you're being pushed out, but the force doesn't actually exist. You feel a centrifugal force merely because your inertia wants you to go straight, so the car ends up slamming into you like this. In fact, if there was a centrifugal force instead of the inward pointing centripetal force, when you let go of a ball spinning on a string, instead of flying away at a tangent, it would fly outward like this. Now imagine that happening to your car.